video, we are going to explain about the project title Real-Time Localized Air Quality Monitoring and Prediction through Mobile and Fixed IoT Sensing Networks. Air pollution and its harm to human health has become a serious problem in many cities around the world. In recent years, researchers interested in measuring and predicting the quality of air around people has peaked. Since the Internet of Things has been widely used in the different domains in improving the quality life for the people by connecting multiple sensors in different places, it also makes the air population monitoring more easy than the previous. Traditional ways of the using fixed sensors cannot effectively provide a comprehensive view of air population pollution in people's immediately surroundings. Since the closest sensor can be possibly miles away, our project was focusing on the modeling the air quality pattern in a given region by adopting both fixed and moving IoT sensors, which are placed on the vehicles patrolling around the region. With our project, a full spectrum of how air quality varies in nearby regions can be analyzed. We demonstrate the flexibility of our approach and in effectively measuring and predicting air quality using different machine learning algorithms with the real world data. Our evaluation shows a promising result for effective air quality monitoring and prediction for the smart city application. In this project, we are going to mainly focus on the prediction of air quality by using the fixed and mobile sensors to the sense environment data. By using different algorithms of machine learning such as random forest, support vector regression, gradient boosting regression, and long short-term memory. Hardware requirements, we need operating system, Windows processor, i5 and above, RAM 4GB and above, hard disk 20GB and above. Coming to the software requirements, we need to install Python with the version of 3.7. Methodologies. To implement this project, we have designed few modules. First one, upload dataset. Using this module, we will upload the dataset to this application. Second one, pre-processing dataset. Dataset contains missing value and this value will be replaced with a zero values by applying data pre-processing. Next module, run PM2.5 prediction. Using this module, we will run all four algorithms on PM2.5 values and dataset to predict PM2.5 for next 30 days and then calculate prediction RMSE error between all the algorithms. Fourth module, run PM10 prediction. Here also we will run all the four algorithms by using PM10 parameters and then predicting PM10 for next 30 days and then calculate RMSE error rate between all the algorithms. Fifth module, graph. Using this module, we will display the RMSE error rate from all the four algorithms from PM2.5 and PM10. Execution. Coming to the execution, close this file and go to the code file. This is the code file consists of dataset file with the city data, and this is the main code file, and this is PM.25 file data, and this is PM10 datasets, and this is the main runbat file. This runbat file, instead of executing the command line interface, we created Windows bat file to execute the program. By clicking double tab on it, it leads to the user graphical interface, which we creates the graphical interface which is interactive to the program user. Now click on the first button, upload air quality prediction dataset. By clicking this button, you can see the dataset and click on the button and click on the open button. Now you can see that all the datasets which are attributes which are found in the dataset was existed. Now click on the pre-processing dataset. By clicking this button, you can see whatever the dataset consists of, all the missing values are replaced with a zero, and you can see the graphical representation of a PM2.5 population rate and also according to the date. In the x-axis, you can see the date from and for, and in the y-axis you can see PM2.5 population rate. Close this graphical representation and click on the run button. Run PM2.5 prediction. By clicking this button, you can see in the console the gradient boosting and SVM and random forest algorithm before the next 30 days was predicted. So in this value, whatever the console is showing that we are going to upload the dataset based upon the 4 algorithms and then predict PM 2.5 for the next 30 days and then calculate RMSE score. You can see the console that long short-term memory, random forest, support vector machine and also gradient booster was generated. Now minimize this graph and you can see here on the graphical user interface the existing algorithms. By using the 4 algorithms PM 2.5 accuracy will be predicted on the graphical user interface. So this is mainly used for the next 30 days prediction values. So you can see here accuracy graph of a gradient booster, support vector regression, random forest regression and a long short-term memory algorithm. These are the not the accuracy but RMSE score errors. Now click on the run PM10 prediction. Now see the console. Here also we are going to generate the 4 algorithms based upon the next 30 days. And also here we are going to predict with the 4 algorithms that are random forest, support vector regression, gradient boosting and also long short-term memory. So these models were generated here, and now then here we will be seeing the approaches for the long short-term memory. And here in the PM10 values for the last 10 days were calculated and also trained, and then we will be having the algorithms, 4 algorithms, and also then predicted with the PM10 for the next 30 days and calculates the RMSE error. And the console, in this console we will be having the dimensions for the long short-term memory and also approaches which we have in the long short-term memory built the algorithm. Now you can see the graphical representation of the different types of 4 algorithms which was predicted here. So in the x-axis the count of the samples which were there, and in y-axis you can see the error rate. So this is red line indicates the actual value and green line indicates the predict value. This is a graphical representation of the prediction graph for the 4 algorithms based upon the PM10 data set attribute. Now close this graph and you can see here PM10 RMSE score error. Now click on the button comparison graph. By clicking this button comparison graph, you can see the graphical representation of different types of algorithm based upon the PM10 and also PM 2.5 RMSE score error. So based upon this all the algorithms, we have got LSTM algorithm has the less RMSE score error, and in the x-axis you can see the label of the graphical labels of the algorithms, and y-axis you can see the frequency level of RMSE score error. Now close this graph and close the complete code execution. Now go to the conclusion. In this project, we have found that predicting on the performance of algorithm, different 4 algorithms we have trained here based upon the PM 2.5 and PM10 parameters. So by the values for the next 30 days, it was predicted and calculated the RMSE score, error rate between available datasets and actual values and predicted value. From this all the prediction, we got low RMSE score and better the performance of the accuracy score is random forest algorithm and also long short-term memory algorithm.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.